Good morning, our students, and welcome to today's class. Today, we want to discuss a very important topic in statistics called expected value or expectation of a discrete random variable. Expected value or expectation of a discrete random variable. Expected value or expectation of a discrete random variable. Permit me to write R dot V as random variable. Expected value or expectation of a discrete random variable. What do we mean by expected value? Or what do we mean by expectation of a random variable? Another name of expected value of a random variable is the mean of that random variable. So expected value or expected value equals mean of a random variable. Okay. So the question becomes, how do we denote expected value of a random variable? We say, consider a random variable defined say x, or consider a random variable defined by x. Consider a random variable. Consider a random variable defined by x. The expected value now is denoted by, e of x. So anywhere you see in statistics or even in mathematics where they write e of x, they are talking about expected value or expectation of a random variable x. If they write e of y, they are talking about expected value or expectation of a random variable y down the line. So today we want to look at the expected value or expectation of a random variable when that random variable is discrete in nature. So we are going to define the expression or the formula of expected value of a random variable x when that x is discrete in nature. It is given as e of x is defined as sum over the range of x p of capital X equals small x. This is the definition of the expected value of a random variable x when x is discrete in nature. Sum over the range of x, p of capital X equals to small x, where this p of capital X equals to small x is the probability mass function. That is the probability distribution or the probability function of a discrete random variable. So this is the definition here. So we are not going to waste time. The moment you know this definition, all we want you to understand about the expected value of a discrete random variable is finished. So we just want to go into solving problems now. So permit me to clear here while we begin to take questions. What if somebody gives us an information or gives us information that a fair die is rolled once. A fair die is rolled once. So let me now have question number one. A fair die is rolled once. Obtain I sample space I probability distribution I E of x, or expected value of the experiment. So we quickly start with solution. First one, question I says sample space. Okay? When you talk about sample space, you are talking about the set that contains all the possible outcomes of a random experiment. And the experiment that is involved here is rolling a fair die once. A fair die contains 6 faces. So the first outcome could be 1, it could be 2, it could be 3, it could be 4, it could be 5, and it could be 6. So these are the possible outcomes. The set containing these possible outcomes is what we refer to as a sample space. And this sample space is often denoted with a capital letter S. So I'll now come and say S here is given as a set that contains 1, 2, 3, 4, 5, and 6. This is the sample space of this experiment. The second question here says, I here, probability distribution. When you talk about probability distribution, oftentimes you are talking about the possible values of that random experiment with its probabilities. The possible values of that random experiment with its probabilities. So we are going to represent it with a table, where the first row of that table is the possible values of that random experiment, and the second row is now talking about the probabilities of those values. So I here, then I have a table this way, I have a table this way. I have here is my x, here is my P of capital X equal to small x. P of capital X equal to small x. Then I have this. The first value of that random variable here is what is 1. So I have here 1, 2, 3, 4, 5, 6. These are the possible values. So I'm now going to talk about the probability that random variable capital X will take a value small x, and this small x here is talking about 1. That is probability that capital X equals to 1. That is probability that fair die lands with the face written 1. And you know that in a fair die, when it is rolled, the probability of all the faces are equal. The probability of obtaining what? 1 is 1 over 6. The probability of obtaining 2 is 1 over 6. Because that place that contains 1 is just one face. The place where 2 is written is also one face. The place where 3 is written is also one face. So it is that face that shows up all over the total number of what of the faces. So when it lands with 1, where it is written just like this, where we have just a dot there, where we have just a dot, permit me to clean up the ink. Where we have just what? Dots on the face is one face. All over the total face, which is 6. So the probability here is 1 over 6. When we come to where the 2 is, it's just like this. And it's just one face. 1 all over 6, we still have 1 over what? 6. When we have 3 of them, it is still one face that is showing up. 1 all over 6, 1 all over 6, 1 all over 6, and 1 all over 6. This is the probability distribution. Okay? Then we now talk about the third question here says we should obtain the expected values. To obtain the what? The expected value. So the expected value, of course, we have our I. We already said that the expected value is E of x, and it's given as sum over the range of x, P of capital X equal to small x. This is now very simple. So permit me to come up here so that we can finish it up here. So I draw a line this way. When I come here now, here is talking about sum over the range of this x. X begins from 1 and ends at 6. So we are going to start from when it is 1. When it is 1, what becomes this x is now 1. P of capital X equals to small x. Now the probability when x equals to 1. And probability when x equals to 1 is what? 1 over 6. So which means I will say that this is equals to, the value of x is 1, here is 1. 1 multiplied by. P that x equals to 1 is 1 over 6 multiplied by 1 over 6. I will say plus because sum means plus. I will come here. When x is now what? 2. Here is now going to be 2. So I have 2 multiplied by. Probably that x becomes what? 2 is 1 over 6. So I have 1 over what? 6 plus. Here. X has become 3 here. So I have 3 multiplied by. Probably that x is equals to 3 is 1 over 6. Plus. Dot, dot, dot. 2. When x is 6. So I have 6 multiplied by 1 over 6. So to bring it up here so we can clear it very well, 1 times 1 is what? Is 1 all over 6 plus. 2 times 1 is what? 2 all over what? 6 plus. 3 times 1 is what? 3 all over what? 6 plus. The next one is 4. 4 times 1 is what? 4 all over what? 6. The next one is 5. 5 times 1 is 5 all over 6 plus. Here is 6 times 1, which is 6 all over what? 6. The LCM of 6 is 6. So I have this thing becomes what? 6. 6 divided by 6 is 1. So 1 times 1, 1 plus. 6 divided by 6 is 1. Times 2 is what? 2 plus. 6 divided by 2, 1 times 3 is what? 3 plus 4 plus 5 plus 6. This is 3. This is 6. This is 10, this is 15, and this is 21. So this thing becomes what? 21 all over what? 6. I guess something can go here, 3 can go. So if 3 goes here is what? 7, and 3 goes here is what? Is 2. And if you divide this 9, it will give you 3.5. So the expected value of that random experiment is 3 over 5. So when a die is rolled once, the sample space is given as this. The probability distribution is given as this. Then the expected value is given as this. The first one. Then let me quickly clean here and give us another kind of question. I don't want to believe anything is difficult here. So permit me to clean here and give us another one. That one which I want to give is type number 2. Number 2. What if someone tells us that 2 fake coins are rolled up once? 2 fake coins. 2 fake coins are tossed up once. Obtain sample space, II, range space, I, probability distribution, please, this thing stands for probability distribution. IV, expected value E of X. So let us quickly solve together to manage the size of this video. So let us be a little fast. So I'm beginning with solution. So this solution. Okay. The first one says sample space. When we talk about sample space, it is the set of all the possible values or all the possible outcomes of that random experiment. And know you that if you carry two coins in your hand and you toss them up together, you can be very lucky. This one will land with head, this one will land with head. So the sample space S here now, which is I now here, the sample space S is given as. If you toss both of them and they land with head, you have head, comma. Then you can toss both of them. This one will land with head, the other one will land with tail. Then you have head, tail. It is possible that this first one becomes tail and the other one becomes what? Head. And you have tail, head. And it is possible that both of them will land with tail. These are all the possible values that you can have when two fake coins are tossed up together. Now, for us to obtain the range space, we are going to be very, very careful here. We are going to define a random variable. For us to obtain the range space, we are going to define a random variable, say x. Say what? X. So I have II. We are going to define a random variable, say x. And this random variable now is going to count for me either the number of heads or the number of tails in each of the outcomes. Okay? So I now have a set which is R of x. This random variable x is counting for me the number of what heads. And this R now is talking about range space. So this is equal to a set. When you come to this first row here, how many heads are here? There are 2 heads. So here becomes 2, comma. When you come here, this is 1 head, so 1, comma. When you come here, this is 1, comma. When you come here, there is no head at all. It becomes 0. You close it. And of course, you are defining this as a set. And in a set, it is not proper to replicate numbers. You understand? So here 1 appeared and here 1 appeared. So I need to remind you that this is the same thing as writing this 2, 1 and 0. This set and this set are the same thing. Because here, repetition of number in a set doesn't count. So this and this are the same thing. So this is the range space. Because if you remember in our previous classes, we explained that the range space, or that when you talk about what range space, you are talking about a set that contains real values or numerical values of all the possible values of a sample space. These are real values or numerical values assigned to all the possible values of the random experiment, or all the possible values of what in the sample space. Then we now talk about the probability distribution. Probability distribution. When we talk about probability distribution, we are equally going to use a table. So in that II, we use a table. That table is going to be something like this. We have our x. We have P of capital X equals to small x. So we now have this. and we have this. The least value here is 0, so we'll start here 0, 1, and 2. We want to obtain the probabilities. Here we have 0. Remember that we had 0 here when we met an outcome where we did not have head at all. And there's only one place where we did not have head. And the total outcomes here is 1, 2, 3, 4. So when I want to obtain the probability of TT, that is 2 days, it is 1 all over 4. Which means the probability here becomes 1 all over 4. Then when we have here 1, remember that we had here 1 and we had here 1. That is now where we had a 1 head and where we had 1 head. So this outcome we have 1 head, this outcome we have 1 head. So in 2 outcomes we have a head there. The total outcome is what? Is 4. So it is going to be 2 all over 4. And 2 all over 4 will now be, this is 2 all over what? 4, which becomes 1 all over what? 2. So here is 1 all over what? 2. Then here we had what? 2. Here we have 2, and here we had 2 when we talked about the head here. And it's only one place that it occurred out of 4. So it becomes what? 1 all over what? 4. This is what we call the probability distribution. When 2 fair dice are tossed up once. Then we talk about the expected value E of x. Expected value E of x. My E of x is given as sum over the range of x P of capital X equals to small x. You close it. So this equals. When my x is 0, the probability that x takes a value 0 is 1 over 4. So it is going to be, this is my x in place of this. So 0 times, it is 1 over 4, 1 all over what? 4. I come here. X becomes what? 1 multiplied by P that x is 1 over 2. So here is 1 over what? 2 multiplied by x becomes 2. So I have what? 2 times. Probability that x becomes 2 is 1 over 4. So I have 1 over what? 4. This equals. When 0 multiplies everything, it is 0. So everything here is gone. 1 times 1 is 1 all over 2 plus. 2 times 1 is what? 2 all over what? 4. LCM of 2 and 4 is what? 4. 4 divided by 2. 2 times 2 is what? 2 plus. 4 divided by 4, 1. 1 times this is what? 2. This is equals to 4 all over 4, which equals to what? 1. So the expected value is 1. When 2 fair dice are rolled up once. The assignment I will give you now is try to see whether you can obtain the sample space, range space, probability distribution, and E of x when 3 fair coins are tossed up together. Use this approach which I used here. When 3 fair coins are tossed up together. Try to see whether you can get all what we have got here. Okay? Thank you very much. So permit me to clean here, and we'll talk about something else. Okay, we can come to a place where the P of capital X equals to small x is given to us, and we are told to find the expected value. Okay, we are told to find the E of x. For instance, let me call this one number 3. And they say let P of capital X equals to small x be given as C all over what? 10. Or let me use x over 10. Then for x equals 1, 2, 3, and 4. The question here says, obtain E of x. Obtain E of x, expected value of x. To obtain E of x here, you are equally going to use that our usual way, that my E of x equals sum over the range of x, P of capital X equals to small x. Okay? So to solve this, is equals. When x becomes 1, look at my 1 here. What I'm now going to have is 1 multiplied by, here equally becomes 1. 1 all over 10 plus. When this x becomes 2, what I'm going to have is now 2 times. Here equally becomes what? 2. So I have 2 all over 10 plus. When this x becomes 3, I have 3 times. Here equally becomes 3. So I have 3 all over 10. And then when x becomes what? 4, I now have plus 4 times. Here equally becomes 4 all over 10. So this will give me 1 times 1 is 1 all over 10. 2 times 2, 4 all over 10. 3 times 3, 9 all over 10. 4 times 4, 16 all over 10. LCM is what? Is 10. 10 divided by 10 is 1. 1 times. So this becomes 1 plus 4 plus 9 plus 16. This plus this is what? Is 5. This is plus 16. This plus this is what? In fact, this plus this is 10 plus this is 14. 14 plus 16. 14, 16. Bring down 0. Here becomes what? 30. So this equals what? 30 all over 10. So that this and this can go, and the expected value is 3. So you see how to obtain the expected value. Okay? This is how to obtain the expected value. So they can equally ask us to find what I'm going to define now. Let me clean this. I don't think whether there's anything difficult here. So let me clean here, and then we draw up a question here. Let me clean this place. Let me pick up the question here. Okay, let us solve this problem. Say P of C equals to X, Cx, given 1, 2, 3. Obtain C, obtain the probability distribution, and obtain the. Look at the question. Let me call this one number 4. Say, given that P of X equals what? X is given as Cx. For X equals 1, 2, 3, 4. They say obtain I, C, E of X. I'm going to be fat here. To solve this kind of a problem, you want to first of all obtain C. To obtain C means that the sum of all this probability over this range will give you 1. To obtain C, it means that is I now, that sum over the range of X of P of capital X equals to small x must give you 1. That's what it means for you to obtain this C. So this equals, you are summing sum over the range of X. P of capital X equals to small x is defined as C of X. So you have C of X equals what? 1. This C is constant and it can be brought outside. So this is C sum over the range of X is equals to 1. So this is C equals, or C, you open a bracket. You are summing the values of X. Look at the values of X. 1, 2, 3, 4. So you have 1, because this is X, plus 2, plus 3, plus 4. You close it. This is equals to 1. This plus this is 3, to this is 6, to this is 10. So you have C into 10 is equals to 1. C times 10 is 10C equals to 1. To make C stand alone, all over 10, all over 10. This cancels. Therefore, my C is equals to 1 over 10. I will obtain the value of C, 1 over 10. Okay? So for me to obtain E of X, I have known that my C is 1 over 10. So I will return back here. I will say therefore, my P of capital X equals to small x is given as, this C is already 1 over 10. So I have 1 all over 10 times x, this x that is here, which is now x all over 10. So for me now to obtain that E of X, I'll say therefore my E of X is equals to sum over the range of X, P of capital X equals to small x. This is equals. My X is that already here. This is my function. In fact, this is all the same thing we solved earlier. So when X becomes 1, we have 1 times. Here X will now be 1 over 10 plus. When X becomes 2, I have 2 times. Here now becomes what? 2 over 10. 2 over 10. It becomes 3 times 3 over 10 plus 4 times 4 over 10, which is exactly what we solved earlier. So you can easily evaluate that. Okay? We actually have properties of expectation, which I want to quickly write down here. Properties of expectation. So you permit me to clean here while I write it down. Properties of expectation. Properties of expectation. Number one, we have that E of AX is equals A E of X if A is a constant. If A is a constant. And we have number 2, that A of AX plus B is given as A of E of X plus B if A and B are constants. Are constants. These properties are very important. Okay? Now, in that note, it means that if you solve, if somebody asks you now, if they say, given that, for instance, given that E of x equals what? Equals 2. They say obtain I E of 4x. E of 4x, I E of 4x plus what? 3. And the same thing applies here. Okay, let me add it here. I E of 4x minus 3. For you to solve this solution, if you come here, this information has been given to you here. So you now say that E of 4x equals to 4 E of x. And you are told that E of x is 2, so this equals to 4 times what? 2, which is equals to 8. You come here. This information has been given to you. You now tell yourself that E of 4x plus 3 equals 4 E of what? Of x plus 3. E of x is 2 already. 4 times 2 plus 3. This is 8 plus 3. And this is 11. You come to the other one. E of 4x minus 3 equals what? 4 E of what? Of x minus 3. This is equals to 8 minus 3, which is equals to 5. So these are some of the properties of expected value of random variable. Okay? There are a lot of other things that we should have to solve here, but for the size of the class on YouTube, we are going to stop here. Thanks for your audience, and wait for us in our next classes.